Two blocks of mass m and 2.5 kilograms respectively are connected by a light inextendable string. The string runs over a light frictionless pulley as shown in a diagram below. Okay, so basically in the diagram, this is what's happening. Now, this is what you would see in your free body diagram, right? It would be a normal force acting on mass m, a frictional force pulling in the opposite direction, while the other force is hanging. Okay. Now, the blocks are stationary. Question 2.1.1, state Newton's third law in words. Basically, it means when a force is applied to an object, the object applies an equal but opposite force back on the other object, right? If you are pushing against the wall will push against you in an equal but opposite force. Hence, these blocks are stationary. This means that the frictional force is equal to the weight that is pulling down on the string. 2.1.2, calculate the tension in the string. If we use what we just learned or what we just said from Newton, we know that the frictional force is equals to the tension in the string. Hence, the whole system is stationary. Now, the tension in the string is held up by the weight of the 2.5 kg that is hanging. Now, what is weight? Weight is mass times the gravitational force. So it's going to be 2.5 multiplied by 9,8, which will give us 24.5 newtons. Okay, I'm happy with that. Now, the coefficient of friction in the string between the unknown mass m and the surface of the table is 0.2. Calculate the minimum value of m that will prevent the block from moving. Okay. So, what we have said here, we have said that the frictional force is equals to the tension, and now we know the tension to be 24. So, what we can do, we can say that again, we can say the frictional force is equals to the tension. Now, we can come here and say that the frictional force is equals to weight multiplied by the coefficient of friction. Okay, now we can come here and say that because we've said that the frictional force is equals to the tension, we can say that tension is equals to weight multiplied by the coefficient of friction. Then that means weight will equal to tension divided by the coefficient of friction. So we can say 24.5 divided by 0.2. I'm going to put that in our calculator. So 0.2, we get a total weight of 1, 22.5. That is the weight. Okay. Now, the weight could also be known as the normal force, right? The normal force is equals to mass times gravitational acceleration. So we can say that 122.5 newtons is equals to mg. That would make m equaling 122.5 divided by 9,8, which would give us a mass of 12.5 kilograms. So that's the minimum mass that we need to keep the system from moving. Okay. Now, the block of an unknown mass, m, is now replaced with a 5 kg mass. The 2.5 kg block now accelerates downwards. The coefficient of kinetic friction between the 5 kg block and the surface is now 0.15. Now, calculate the magnitude of acceleration. Okay, that's a very loaded question. Okay, so we now have two masses that are moving. Okay, so because the system is no longer stationary, we need to now find frictional force. We have the tension, and we have two masses of 5 kg and 2.5. So now they want us to find the acceleration. Okay, so first we can say that F net is equal to mass times acceleration. Remember, this acceleration is not the 9,8. That's the gravitational acceleration. Do not mix the two. Okay, so we need the acceleration of the total system. Okay, we can say that frictional force is equals to weight times the coefficient of friction. We have 5 kgs times 9,8 times 0.15. We can get the frictional force. So it's 5 times 9 times 9,8, which is the weight, times 0.15. We have 7.35 newtons. Okay, we have 7.35 newtons. That's our frictional force. We already have the tension of the 2.5 kg, right? So you can say put that in a box. Okay, let me also get rid of this. So that I can say that the tension is equals to the weight, right, which is 2.5 multiplied by 9,8. Essentially, that is what is pulling the system down, and we already know that it's 24.5 newtons. Okay, put that away there. Now I can say mass total is equals to 5 plus 2.5, which is going to be 5 plus 2.5. which is going to be 7.5 kgs. So that is the total mass. Now, we know, because of Newton's second law, we know that F net is equals to mass times acceleration. F net is the tension minus the frictional force, because the frictional force is acting on the table. Remember here, frictional force, you see, it's acting in the opposite direction. The 2.5 kg is pulling the two masses downwards. So that friction between the table and the mass, now that's gonna be working against the whole system. This is why we need to subtract the frictional force to get F total, which will equal mass times acceleration. The mass, you must add the two masses, because now they are accelerating together, they are moving together. So we're going to say 24.5 minus 7.35 equals 7.5 A. Then A would equal to 2.29 meters per second squared. And that is how you would answer an exam question.